Good evening, everyone. This is a question that we went over today on today's help session. It should be relatively simple. I wanted to correct some errors that we had in the problem originally. So I wrote this up, and I did almost all the setup and the algebra to get us to the final step, solving the quadratic. And then I'm going to leave that to you, but the key is that I'll just walk you through this video, and that should be pretty good. So we've got the sum of the two charges up here, which is 9.64 times 10 to the negative fourth coulombs. We've got the tension is 3.4225 times 10 to the third newtons. We've got that the radius is 7.8 times 10 to the negative 1 meters. And then using this, I derived that Q1 is equal to 9.64 times 10 to the 4 minus Q2. So the reason we know that that works is because these are both positive, since this is positive, and they're the same polarity. So then it's just, we don't have to have an absolute value like we did with the string problem. Moving down here, since there's only one force we're concerned with, we don't need any up or down forces, there's no friction, so we're only concerned with tension and the electric force. So we're left with Ft equals kq1 q2 over r squared. Just set the forces equal, treat this side as fixed. I even said that, fix this side. So we get 3.4225 times 10 to the third is equal to 9 times 10 to the ninth over 7.8 times 10 to the negative 2. And this is because that's 10 to the negative 1 squared. All I did here was just make sure that I squared this and this separately. I think I had spoken before about separating out powers of 10. So I'm doing that again here. I'm separating the power of 10, squaring it, and the decimal value and squaring it, times Q1, Q2, which leaves us with this equation here. So we get FT r squared over K is equal to Q1 times this formula we worked out for Q1 in terms of Q2. So now I'm going to move this up, and we're going to solve as best we can. I'll set up everything except for the last calculator step because I think that it's pretty self-explanatory once you get to this step, and the only thing that you could be missing from there is just powers of 10. So we get 3.4225 times 10 to the third times 7.8 squared times 10 to the negative 2 over 9 times 10 to the negative 9 is equal to, I'm going to erase this, and that's Q1 times this. It's equal to Q1 times 9.64 times 10 to the 4 minus Q1. Okay, so we've got an expression. We can create a quadratic here. We've got negative Q1 squared plus 9.64 times 10, I'm going to draw an arrow here, times 10 to the fourth Q1 minus all of this. So let me make sure that this is clear that I have this separated off real quick. So that's minus 3.4225 times 10 to the third times 7.8 times 10 to the negative 2 over 9 times 10 to the 9 is equal to 0. And again, I'm going to erase this and move the solution up. So let's cancel out some powers of 10. This power of 10 right here and this power of 10 cancel out to give us just a 10 to the 1 right here. So this is 10 to the 1, or 10. And then this power of 10 and this power of 10 cancel out to give us a 10 to the negative 8. And that's just 9 there. So we've got negative q1 squared, I'm trying to write this as neat as I can, plus 9.64 times 10 to the 4th q1 minus 3 point, I'm going to erase this, 4225 times 10 to the negative 8 times 7.8 over 9 is equal to 0. Now here's our quadratic. Let me put these in various colored parentheses so we can see them better. There's one term, there's the b term, and there's the a term, which is a negative 1. So, negative 1. Now, for the quadratic, we get negative b, so negative 9.64 times 10 to the 4th plus or minus the square root of b squared, which is 9.64 squared times 10 to the 8th. Minus 4 times negative 1, so plus 4, times this junk. So let's write that in a different color so we don't miss any terms. 4 times 3.4225 times 10 to the negative 8 times 7.8 over 9 over negative 2. And sorry for how small the numbers are, but I'm going to erase everything and write this big and let you work out the actual solution in the calculator. Once you have one q, you have the other q. So let me do that real quick. Let's make sure that that's correct. We've got that 9.64 times 10 to the negative, 10 to the negative 4, so this is negative 8. That's a good catch. It's a good catch right there. That's 9.64 squared times 10 to the negative 8, which means that both of these are in terms of 10 to the negative 8. And we can actually pull that out. So let's start by, I'll walk us down to the last step that I can without a calculator. We've got Q1 equals negative 9.64 times 10 to the negative 4 plus or minus, and then I'll pull this 10 to the negative 8 out. So you get 10 to the negative 4 times the square root of 9.64 squared plus 4 over 9 times, and that's 3.4225 times 7.8. All right. So we can also pull this out. This is a 2/3. Or let's just actually leave it at this. This should be our answer. These are the same order of magnitude. Make sure that's right. 9.64 to 10 to the negative 4, negative 4. So we can actually even factor 10 to the negative 4 out of here again. Just work out that power of 10. And then we've got all this, so 9.64 plus or minus. And then this is square root of 9.64 squared plus 4 over 9 times 3.4225 times 7.8 over -2. All right, so -2 is from up here. This should be your answer. If you have any serious questions about this, we talked about doing power of 10 calculations earlier. This number should be positive. I believe it has to be positive because this is greater than 9.64. And negative 9.64, we can choose the negative sign here, minus all this stuff over -2 is going to give us a positive term. So we're going to choose whichever sign here gives us the positive term, since we know that both charges are positive. So we're going to choose the positive solution. All right, that should do it. I'm going to post this and the help session from today on YouTube in the next hour or so. Thank you.